Hello everybody, in this lesson I will deal with two difficult quadratic equations with fractions. Example 3. Solve for x in and then I give you an equation that contains fractions. Now if you look at this sum, the steps are factorize all denominators. And that is a very important step. So if you look at the first term, you can see that you can pull out 2 as a common factor on the first term. The second term, when we factorize x squared minus x minus 6, we end with x minus 3 bracket x plus 2. And the last term, we cannot factorize, it's just x minus 3. But be careful here on the first term, we can still factorize the x squared minus 4. That's the difference of two squares. So we can factorize it further into 2 bracket x minus 2, x plus 2. So now all denominators are factorized. Step 2, let's find the restrictions. So first of all, the restriction we find by looking at the denominator. And we find under the line x minus 2, therefore x cannot be 2. And we find x plus 2, x cannot be negative 2. We find x minus 3, therefore x cannot be plus 3. So that is how I got to the restrictions. And then for the LCD, I go to the first term. Under the line, I find a 2, x minus 2, and x plus 2. Now I go to the next term, and suddenly there's a x minus 3. So I add that one to the LCD. And then there's a x plus 2, but x plus 2 is already represented at the LCD. And on the last term, I find x minus 3, but x minus 3 is already there. Then, in the next step now, step 3, multiply all the terms by the LCD. So what you do is you're going to write here, 2 bracket x minus 2, x plus 2, x minus 3. And then the second term as well, we multiply with the LCD. 2 bracket x minus 2, x plus 2, x minus 3. And the last term, multiply with LCD. 2 bracket x minus 2, x plus 2, x minus 3. And then what happens is x minus 2 and x minus 2 can cancel, and x plus 2 and x plus 2 can cancel. And I'm left with, and the 2 and the 2 can also cancel. So I'm just left on top there with 1 bracket x minus 3. On the second term, x minus 3 will cancel, and x plus 2 can cancel. And I'm left with this 2, that 2, and x minus 2. And then on the last term, on the right-hand side of the equal sign, the x minus 3 and the x minus 3 can cancel, and I'm left with this one, if you want, 2, x minus 2, and x plus 2. Then, in the next step, I'm going to multiply out everything that I can. Therefore, I end with, when I multiply in this one, I end with x minus 3. And now this 2 times 2 becomes a 4. And now I'm going to multiply in this 4. So it's 4 times x is 4x. 4 times negative 2 is negative 8. And then here on the right, what happened was I multiplied out the 2 brackets x plus 2, x minus 2, and they became x squared minus 4. And then I'm going to add all my like terms on the left. So x plus 4x is 5x, and negative 3 negative 8 is negative 11. And on the right, I'm going to multiply in the 2, and it becomes 2x squared minus 8. Now I'm on step 4, where in this one, I'm going to get the right-hand side and equal to 0. So everything will just walk across. And please note, I write it in a proper descending order. 2x squared minus 5x plus 3 equal to 0. Now step 5, factorize. So when I factorize that bracket, I end with 0 equals bracket 2x minus 3, x minus 1, and I solve x, and x is equal to 3 over 2, or x is equal to 1. And then final answer, check your answer against the restriction. So the restriction was x cannot be negative 2, 2, or 3. And in this case, x is 3 over 2 is valid, or x is equal to 1 is also valid. Example 4, solve for x in, and then I give you the equation that contains fractions. Now, the first problem we find here is in the denominator on the second term, there's a negative in front of x squared. So step 1 is we have to make x squared's coefficient positive in the denominator. And the way you do that is, I did it here for you on the right slowly. First of all, you swap the two numbers, or the two terms rather. So it becomes minus x squared plus 1. And then in the next step, you pull out this minus as a common factor. And can you see it then changes that into a plus, and then it changes this into a negative. Now, x squared's coefficient is positive. In the next step, step 2, we factorize all denominators, and the problem is just here on the second term where you find x squared minus 1. That is indeed the difference of two squares. Then in the next step, step 3, we find the LCD and the restriction. So the restrictions, by now you can see, will be negative 1, and on x minus 1, the restriction will be positive 1. And then the LCD, you go to the first term, you write down whatever you find there, x plus 1. And then on the second term, there's already x plus 1, but we also need x minus 1. And then on the right-hand side there's x minus 1. It's already represented in the LCD. So therefore your LCD, x plus 1, x minus 1. Step 4, multiply all the terms by the LCD. So therefore, I'm going to multiply with x plus 1, x minus 1. The first term. The second term, I multiply x plus 1, x minus 1. This one on the right-hand side, I multiply x plus 1, x minus 1. And now they can cancel out. X plus 1 cancel with x plus 1. I'm left with 6 bracket x minus 1. And then on the second term, x plus 1 and x plus 1 will cancel. X minus 1 will cancel. And I'm left with only 3x. And here on the right hand side, x minus 1 will cancel. And I'm left with 2x bracket x plus 1. Then in the next step, I'm going to multiply in the 6 here. So it's 6x minus 6 plus 3x right with. And then on the right hand side, it becomes 2x squared plus 2x. Now, the next step, the right hand side equals to 0. So with that, I mean you will add 6x plus 3x. It's 9x, and then when it walks across, it becomes minus 9x, and then 2x minus 9x is negative 7x, and then the negative 6 will walk across and it becomes plus 6. Step 6, factorize and solve. So when we factorize that one, it's bracket 2x minus 3, bracket x minus 2, and we solve, we find x is 3 over 2 or x is equal to 2. And then let's check the answers against the restrictions. The restrictions were x cannot be negative 1 or 1. My answers are x is equal to 3 over 2 or x is equal to 2, and they are both valid. In the next video, I will explain equations containing surds. Click on the video in the left-hand corner to take you straight to the next lesson. Please like my video.